Hey folks, welcome back to Niche Learns to Code. Today we'll be solving question number 9 on LeetCode algorithms, palindrome number. This video is divided into 3 sections: the problem, the solution / the algorithm, and the code in Java. All sections are there in the timeline below, so if you would prefer to jump to a particular section, you can do so. There's also an analogous video with solution in Python, so if you would rather have a look at that. Let's get started. Let's have a look at the problem. So here we have question number 9, palindrome number. In this question we are given an integer and we need to determine whether it is a palindrome or not. So if the number, the integer, is a palindrome, we need to return true, boolean true, otherwise we need to return boolean false. So let's have a look at some examples of palindrome numbers over here. So the first example that they've given here is 1 to 1, and please keep that in mind. This is not a string, this is an integer. So yeah, so this is 121 number. This is a palindrome because, okay, what is a palindrome? If you've seen the movie Tenet, you probably already know that movie is filled with palindromes. So palindrome is something, if you read it from from the left or from the right, from the front or from the back, it will read the same. So 1 to 1 from the left is 1 to 1, and backwards is also 1 to 1. So hence it is a palindrome, and that is why they have returned true. Another example is negative 121. From front, this reads negative, then 1 to 1. And from the back, this reads 1 to 1, then negative. So this is not a palindrome. One thing, if you notice over here, is that all negative numbers will not be a palindrome, because no matter what negative number that you have, it will always start with a negative sign and then followed by a number. And no number will ever end with a negative sign, because in maths, no number ends with a negative sign. They start with a negative sign. So by default, we can eliminate all negative numbers and call them false, that they're not palindromes. Okay, moving on to 1, 0. From the left it is 1, 0, from backwards it is 0, 1. So we can clearly see that this is not a palindrome and we need to return false. Okay, this is the problem. Now let's have a look at the solution. Here we are. So let us say that we have some number 121, which is a palindrome, and we would like to determine that this is a palindrome. The most simplest solution that comes to mind is convert this integer number to a string. So currently this is an integer number. Now we will have a string 121. Now that we have the string, we can simply iterate over it. So we can have a left pointer, this is the left pointer, we can have a right pointer. The left pointer will move from the left to the center, the right pointer will move from the right to the center. They will keep on iterating like this, and we will check for every character. We will first check, is 1 equal to 1? If 1 is equal to 1, no problem, moving on. The left pointer and right pointer will now point to the center. Is 2 equal to 2? Yes, 2 is equal to 2. No problem, done. So this is a palindrome. Let us say that we had some other number like 1, 2, 5, 4, 5, which was not a palindrome. First, we would have converted this number to a string 1, 2, oh my god, incorrectly written. We would have converted it to a string 1, 2, 5, 4, 5, a string, and then we would have 2 pointers. We would have left pointer, we would have right pointer. As the left is not equal to right, that means that this number will not be the same, whether reading it from the front or from the back. Hence this is not a palindrome. This solution is valid. The space complexity for this would have been big O of n, where n is the length of your number. Let us say that you have a 5-digit number, and if you're creating a string object from that 5-digit number, the length of your string will be 5. If the number is very large, it's a 10-digit number, then the length of the string will be 10. If the number is very small, it's a 2-digit number, the string will be smaller and hence will take up less space. So by that definition, the size of this program depends on how large is your string, and the size of your string depends on how large is your number. So the space complexity for this program, if we can convert it to a string, will be the number of digits in your number. The number of digits in any number in mathematics, n, is log to the base 10 of that number. And the time complexity, once you've converted it to a string, we are iterating over the string, the time complexity would have been the number of digits in the string, and the number of digits once again is log to the base n. So the time complexity and space complexity would have been log of n and log of n if we use this approach, converting to string and then iterating. But there's a catch. It is clearly follow-up. Could you solve it without converting the integer to a string? So converting the integer to string and then solving the problem is actually a good solution, an easy solution, but LeetCode is challenging us. Can you do this without converting this to a string? So let us think of something else. Another solution that comes to mind, and this is the actual solution, is that we can simply reverse the solution, reverse the number. Let's say that we have this number 1 2 5 2 1. The reverse of this number will be 1 2 5 to 1, because obviously this is a palindrome, so whether you read it from the left or from the right, both ways they are the same. So the reverse of this integer number will also be the same. Then we can simply compare, is the original number equal to the reverse? If the original is equal to the reverse, that means it was a palindrome, otherwise it was not a palindrome. So this solution will work, but there is a problem in the solution. The problem with the solution is that the reverse of a 32-bit signed integer may not be a 32-bit signed integer, and this is a problem that we already encountered in a previous problem, reverse integer, on LeetCode algorithms. I'll link that video up there over here. Alright, so let's say that we have this number 1 2 3 4 5 6 7 8 9. This is a valid number, that something that a 32-bit signed integer can store. The reverse of this number 9 8 7 6 5 4 3 2 1 is not something that you can store in programming languages. So if an integer is valid, it is not guaranteed that the reverse of that integer will also be a valid integer value that you can store in your computer programming language. So how do we solve this problem? A quick fix, an excellent fix to the solution will be reversing half of the number rather than the complete number. So let us say that we have our number like this. We have 1441. We will not reverse the entire number, but only half of the number. So reversing half the number is 14, and we can simply compare the first half of the number with the second half of the number, which should be both equal in the case of a palindrome. So let us say that we have this number 1441, and this is our initial number, and on the right hand side we have nothing, we have 0. After the first iteration we will have 144, and on the right we will have 1. In the next iteration we will have 14, and on the right hand side we will also have 14. And now we stop. We say that the left hand side is equal to the right hand side, and hence this number 1441, which we started from, was a palindrome. We can take this approach with some other number also. Let us say we have this number 3587, and on the right we have 0. So then we get 3 5 8 and 7, then we get 35 78, and then we stop. Because the length of digits, we have 2 digits on the left, 2 digits on the right, we need to stop. We don't need to compute any further, because the length of both sides is equal. We can directly compare. If this number would have been a palindrome with equal number of digits on both sides, they would have been equal, and we would have known that this is a palindrome. But because they are not equal, it clearly says that this number 3587 is not a palindrome. So this is a method that we can use, reversing half of the integer to determine whether a number is a palindrome or not. Now there are two cases. The first case, the easier case, is that the number would have even number of digits. I'm not saying that the number would be even. I'm saying that the number of digits in the number would have been even. The second case is that the number would have had odd digits. So we have already seen an example, 2 examples of 2 numbers where the number of digits, I'm not the number, but the number of digits. In both of these examples, the number had 4 digits, but even number of digits. So both halves had equal number of digits, and you can directly compare whether this is a palindrome or not. Now I will take an example of a number which has odd number of digits. So now this is the example. Let us say we have number 1 2 3 2 1. Now we know that this number is a palindrome because the left hand side 1 2 3 and the right hand side 1 2 3 are both same. How will we compare this? We have 1 2 3 2 1 on the left, 0 on the right. 1 2 3 2 on the left, 1 on the right. I'm transferring the numbers. So this 1 I have transferred to this side. Continuing with this approach, then we have 1 2 3 and 1 2 on the right. The next iteration we have 1 2, then 1 2 3 on the right, and now we stop. We were running this iterations, we're running this loop as long as the left is larger than the right. As soon as the left becomes smaller than the right hand side, we stop, because we don't want the digits on the left to shrink further. If this would have been an even number, when both digits become same, like 2 digits, or 4 digits, or 3 digits, whatever, when the number of digits become same, the left hand side will automatically be smaller than the right hand side, or equal in the case of palindrome, and the loop will stop. In the case of odd numbers, we will have more digits on the left and less on the right, so the loop will continue and eventually there will be an imbalance because it's an odd number of digits. You cannot have equal number of digits on after this loop runs on both sides. So on the left there will always be less digits, one digit less than the right. In this case there are 5 digits, so on the left we have 2 or 3. If this would have been 3 digits, we would have received 1 digit and 2 digits. Similarly with 7, this would have been 3 and 4. So with odd, if the number contains odd number of digits, there will always be this imbalance. How do we take care of this imbalance? We know that this is a palindrome. We know that 12 should be equal to 123 in this case. So what do we want? We want to ignore the central number. In any case where we have an odd number, the center number doesn't matter because the center number is always equal to itself. It's only the numbers on the left and the numbers on the right that matter. No matter what the central number is, even if I were to replace 3 with any other value, if this instead of 3 there would have been 7, or instead of 7 there would have been 9, this number would still be a palindrome. So what the value that we have, the digit that we have on the center does not matter. So what we want to ignore this 3 over here. So I want to convert 123 to 12. Converting 123 to 12 is super easy. All I need to do is simply divide 123 by 10 and take the floor. So now here is our algorithm. Our algorithm is this. While the number on our left is greater than the number on the right, we will keep on reversing the number on the right. So, we will keep on taking out digits on the left and putting them in the right. So the number on the right will become 10 times the number on the right plus the last digit. This is left modulus 10. This is percentage symbol, left mod 10. So we're just taking out digits from the left and adding them to the right. And in each iteration, we are also dividing left by 10 and taking the floor. So we're also reducing the value of 10. So when it was 123, we took out 3, put it on the right, and this became 12. Then we took out 2, put it on the right, this became 1. So we're just taking out digits and reducing the number over here. Once this entire loop is done, this loop will only work as long as the left is greater than right and will stop. In the case of even, it will stop for equal number of digits. In the case of odd, it will have one less digit on the left and one more digit on the right. Now we need to see if this is an even number. We want to return. In the case if this is an even number, the left hand side has to be equal to the right hand side. In the case of an even number, this condition needs to be satisfied, that left is equal to right. And not an even number. In the case whether the number has even number of digits, not an even number of digits. This condition needs to be satisfied. If the number has an odd number of digits, then this condition will obviously not be satisfied. Then what condition needs to be satisfied? Then this condition needs to be satisfied, that left has to be equal to right divided by 10 floor. So if one of these conditions is satisfied, if the first condition is satisfied, that means it's a palindrome and the number of digits were even number of digits. If the lower condition is satisfied, that means it is a palindrome and the number of digits in the initial number were odd. If any one of these conditions is satisfied, that means that it is a palindrome. And that's it. Now there is an additional note that we should keep in mind. If we have a number like this, let us say that trailing zeros, 100 or maybe 1000, we know that this number is not a palindrome because the reverse of this number is 0001. But when we use our algorithm, the above algorithm that we have mentioned, our algorithm will run something like this. So our algorithm will be, on the left we have 1000, on the right we have 0, then we have 100, then a 0, then we have a 10, then we have a 0, then we have a 1, then we have a 0. And left is still greater than right. So we have a 0 and we have a 0. So our above algorithm will fail for such cases. For any case where the number is divisible by 10. So any case when the number is leading zeros, so leading single zero or multiple zeros, our algorithm will fail in that case. But we know that for any case where there's a 0 at the end, so any example number, for example we have this number 54320. This is not a palindrome because the opposite of this number 0, 2, 3, 4, 5 is not similar, because the 0 just gets negated. This just becomes 2, 3, 4, 5. No number in maths will start with 0. You can have 0 in the end, you can never have 0 in the start. So this is like not a valid number. This number will never be there. So any number that ends with 0, so that means any number which is divisible by 10 will by default not be a palindrome. So any number that is negative is by default not a palindrome because of the negative sign. Any number that is divisible by 10 is by default not a palindrome. But 0 is a palindrome because 0 from the left is 0, from the right is 0. So any number that is negative is not a palindrome, divisible by 10 is not a palindrome, but 0 is a palindrome. And once these 3 edge cases have been sorted out, we can directly use our algorithm, which will work for every other number. That's it about, let's discuss the space and time complexity as well. The space complexity for this problem. We are receiving an integer and we are creating a new integer value. So we received like the original number, we are creating most right hand of the number. An integer takes constant space. That's not going to take more space or less space. So space complexity is constant. Now let's also discuss the time complexity. We will iterate half the number of digits time. So basically, if there are n number of digits in our number, we are working for half of those digits. So we are taking time directly proportional to the number of digits in our number. The number of digits in our number n are log to the base 10 n. So time complexity is log of n, space complexity is constant. Let's have a look at the solution in Java. Here we are. I'm just going to copy this boilerplate code into my IDE. For those of you curious, I'm using IntelliJ Ultimate by JetBrains. Okay, alright. So the first thing that we know is if our number is equal to 0, then it is definitely a palindrome. The other thing that we know is if our number is negative, that means if it has a negative sign in front of it, then it's definitely not a palindrome. Or if a number has a trailing 0, so that means if a number is divisible by 10, so 10,520, any number which has a trailing 0 is definitely not a palindrome. So in either of these cases, it is not a palindrome. Now we can start with our algorithm. So I'll just create a new variable called reversed half. So because I'm reversing half of the number and I will eventually compare my number with this reversed half. Let's get started. So I will work for as long I have my number x is larger than this reversed half. I will simply update reversed half in each iteration. So reversed half is 10 times reversed half plus the last digit of my number, and I will also update my number in each iteration. So I will just divide my number by 10 in each iteration, and this is floor division. So this will divide by 10 and then take the integral value. So this is automatically Java, this because x is an integer, automatically this is like a floor operation taking integer. Now we need to check in the case where x had an even number of digits, the left hand side, which is now the updated value of x, and the right hand side, which is the reversed half, will have an equal number of digits, and they both should be equal. So x should be equal to the reversed half. If this condition is satisfied, then yes, this was a palindrome. If otherwise, or if x contained an odd number of digits, then in that case the left hand side x should be equal to the reversed half divided by 10. This condition must be satisfied. If either of these conditions is satisfied, then in that case this number x was a palindrome. So let us test out this solution, running the code, and yep, accepted. Let me submit this and we'll see whether this passes test cases or not. Faster than 99.97% of Java online submissions. I want to submit this once again because I tried too fast. LeetCode. Okay, I'm still getting 99. It doesn't matter. This solution is perfect. So the space complexity was big O of 1, constant space, and the time complexity was log of n. In this case, x, log of x. Thank you very much for having me, guys. I'll see you in the next one. Ciao.